So in this question, we are given that you push a shopping cart horizontally that has a mass of 15.4 kg with a force of 13.4 Newton. So this is 13.4 Newton. Now, if the cart start at rest, how far does it move in 2.50 seconds? This is what we have to calculate. So by using the Newton's second law, we can write that the acceleration is net force divided by the mass. And in this case, the only force we have, this F, 13.4 Newton. So 13.4 Newton, mass we have 15.4 kgs. So from here, the acceleration for the cart comes out to be as 0.870 meter per second squared. One thing I missed, I have taken this direction to be positive x. So in vector form, we can write x cap, right? Now, distance we have to find. So for that, you can use the kinematic equations. Delta x, this would be 1 over 2 a t square. I've just used this equation. X equals to x naught plus v naught t plus 1 over 2 a t square. Initial position x naught, we have taken it to be origin, so this is 0. Initial velocity is 0, so that is why this x we have half at square, so that is equals to 1 over 2. Acceleration we have 0.870 meter per second squared, and time is 2.50 and it's squared. Now from here we can solve it for this delta x, and that comes out to be as 2.72 meter. So this is the distance traveled. So in this question, we are given that a ball whose mass is 0.53 kg initially at rest, so v naught we have 0, is given a speed of 12 meter per second. So this is the final velocity becomes 12 meter per second during a time interval of 4 milliseconds. So time we have 4 times 10 to the power minus 3 seconds. Now we need to find the average force exerted on the ball during this time. Okay. So first we can find the acceleration, and then we can use Newton's second law of motion to find the force. So V equals to V naught plus AT. V naught we have 0, and this direction we have taken to be positive x. Final velocity becomes 12. A as it is, t we have 4 times 10 to the power minus 3 seconds. So from here, A we have 12 over 4 times 10 to the power minus 3 seconds, and this is meter per second. From here, this acceleration comes out to be as 3000 meter per second squared. Now it's pretty simple. Force is mass times acceleration. Mass we have 0.53 kg, and acceleration we have 3000 meter per second squared. Now from here, you'll get the value of force to be 1600 Newton. So this is the required average force that should be acted on the ball during this time. Now in this question, we are given that object of mass 0.5 kg is acted upon by a force, and its variation of x component for a force with time we are given in this figure. Now we need to draw the corresponding ax versus time graph. So here I'm writing ax and here I'm writing time. So this graph we have to draw. Now according to the Newton's second law of motion, we can write that ax is equals to sigma fx divided by mass. Now from here we can conclude if mass is constant, then acceleration is proportional to the force, right? So if you consider this, here force is 1 Newton and acceleration will be ax, this would be 1 Newton divided by the mass, which is 0.5, so that will be 2 meter per second squared. So a graph will start from here. It's a horizontal line, and here it will be 2 meter per second squared. Then it will going to increase up to, this should be double of this number. 4 times 2 is 8, so 8. Here this should be 8 meter per second squared, and then it goes to 0 like this. So here time is 1 second, and here the time is 3 seconds, and here the time becomes 5 seconds. So this will be the corresponding ax versus time graph. Now in this question, we are given that a 42 kg parachutist is moving straight down with a speed of 3.85 meters per second. So it's moving down with speed 3.85 meter per second, right? Then in the A part, we need to find if the parachutist comes to rest with a constant acceleration over a distance of 0.75 meter, then what does the ground exerts the force on her? So to find the force, we have to first calculate the acceleration, and for that we're going to use the kinematic equations. So in vertical direction we can write Vy square is equals to V naught y square plus 2ay delta y. Now from here the expression for the acceleration, this would be Vy square minus V naught y and its whole square divided by 2 delta y. Now the final velocity becomes 0 minus initial velocity we have 3.85, and in the downward direction, so upward direction we have taken positive, so this should be minus 3.85 meter per second and its whole square divided by 2 times delta y. We have the final position minus the initial position. Final position becomes 0 and initial position we have 0.750 meter. Now from here the acceleration ay, this comes out to be as 9.88 meter per second squared, and this value is positive. So in vector form we can write this way, that means the acceleration is acting in the upward direction. This is ay. Now to find the force, we're going to make the free body diagram. So we're going to assume it to be a point object. The gravity force would be acting in the downward direction w, which is equals to mg, and the force exerted by the ground on the parachutist, this is n, and acceleration is in the upward direction ay. Now we can use the Newton's second law of motion. Sigma Fy is equals to m times ay. Sigma Fy we have n minus mg is equals to m times ay as it is. Now from here n will be equals to m, we can take common, g plus ay. Now we can put the values. Mass we have 42 kg, g is 9.81, standard value ay we have calculated to be 9.88, and from here the value of n comes out to be as 827 Newton, and in vector form we can write y cap. So this will be the answer for the A part. Now in the B part it says if the parachutist comes to rest over a shorter distance, then the force exerted by the ground will be greater, less than, or same as in part A. Now if the distance is shorter, that means this delta y is less. If delta y is less, ay will be more, and if ay is more, then the force will be more. Thus the answer for the B part, it will be greater than A part. This will be the answer. Now in this question we are given that a baseball is traveling with a speed of 92 miles per hour and it comes to rest within 0.15 meter. If the force exerted by the catcher is 803 Newton, then we need to find the mass of the ball. So first what we can do is we can find the acceleration for the ball. So the initial speed is 92 miles per hour. Let me convert it into meters per second. So 92, 1 mile is approximately 1600 meter and 1 hour is 3600 seconds. So the initial speed for the baseball is nearly 41 meters per second, and the final speed becomes 0. Now we can easily find the acceleration. So Vx square is equals to V naught x square plus 2 times a delta x, and from here the expression for this is ax basically. So ax we have Vx is basically the final velocity minus V naught x is the initial velocity divided by 2 delta x. Final velocity becomes 0. Initial we have 41 and its whole square divided by 2 times delta x. Now here delta x is xf minus xi, and the final position is 0.15 meter. Initial position is 0. Initial we are taking it to be origin, so 0.15 meter. From here this acceleration ax comes out to be as negative 5603.3 meter per second squared. Negative means that the direction for acceleration is in this direction. This is ax. Now we can easily find the mass by using the Newton's second law of motion. So ax is the force divided by the mass. Now force is in this direction, so we can write minus, it's 803 Newton divided by mass, and ax we have negative 5603 0.3. Now from here this m will be equals to nearly 0.14 kg. So this is the mass for the baseball.